Okay, so yesterday I derived an expression like something like this. I derived an expression of this format, that is, if I said that if there is a weight that has been shifted from the forward to offside, there is a change of trim, and we derived that the change of trim, which was defined to be L0 C. Okay. We said what is it is W0 W1 plus L0 L1. Like that, we defined that L0 C, the change of trim, is equal to L into W into D by capital W into G0 ML. Now, we know that W into D is the moment causing trim. Okay. Now, therefore, it is producing a trim of L0 C. Now, therefore, small w into D divided by L0 C is the moment causing a trim of 1 centimeter, right. If W into D is the moment causing a trim of L0 C, W into D by L0 C is the moment that is causing a trim of 1 centimeter. That is what we call 1 meter, sorry, everything is in meters here. Initially, we are giving in meters. So, W into D by L0 C is moment to cause the trim of 1 meter. So, the moment to cause a trim of 1 centimeter is this divided by 100. Okay. This is MCTC. Now, therefore, if I say that L0 C is equal to L into W into D by capital W into G0 ML, let me replace W into D by L0 C, I replace it with MCTC into 100. Okay. So, or the other way around, L0 C, let me see, okay, let me do this, 1 is equal to L into W into D by L0 C, which is MCTC, into 100 divided by W into G0 ML. Therefore, L into MCTC divided by capital W into G0 ML is equal to 1 by 100. Okay. Or MCTC is equal to W into G0 ML divided by L into 100. So, this is the final formula. In some case, so what you have here is an expression relating to the here note that we really are not requiring the weight of the weight that is moved. We already defined that a small weight, small w, is moved from one side to another. Without that weight, we are able to calculate, if you are given the MCTC, moment to cause the change, moment to change the trim by 1 centimeter. If you are given that, then you can calculate the everything L0 C, everything using this formula. Okay. So, first you calculate MCTC is equal to W into this. Now, in many cases you will see that G0 ML is in many times replaced by B0 ML, because the difference is not that high. Okay. That means, we assume that G0 and B0 are almost at the same point. By that assumption, it is not exactly true, but some places this formula might be written as, the real formula is this, there is no doubt. Okay. It is definitely G0 ML, but you might see it written as, okay, this is to just facilitate some calculations, because B0 ML, there is another way to calculate B0 ML, you know that. With this you can calculate B0 ML. Okay. Once you are given some parameters of the ship like the length, breadth and all that, you can calculate IL, and from that, and delta also, del also you can calculate, and you can find the, you can solve this equation. Okay. So, that is so this formula is required. Now, this formula is also required along with this. This I already defined, I believe. Okay. If MCTC is the moment required to produce a trim of 1 centimeter, if you have a moment some capital M acting, then the trim produced is M by MCTC. If MCTC is the moment required to produce a trim of 1 centimeter, then if you have some M moment acting, the trim produced is M divided by MCTC. So, that is a change in trim, not trim. The change in trim is given by this formula. So, these two formulas you need. Then I think I stopped here. Okay. Then we will do a couple of problems. You are told that a vessel about to enter a port, this is not the port side, it is to enter a port, has drafts forward. So, draft forward equals 11.2 meters, draft aft equals 12 meters, and if the vessel is to enter port on an even keel, that is a particular word, okay, it is called even keel. Even keel means trim is 0. As the name itself you can guess, it is even keel, you have trim equal to 0. So, if the vessel is to enter port on an even keel, that is a question, if it is to enter a port at even keel, find the amount of ballast water which needs to be transferred from a double bottom. Again some names that you need to know. A double bottom means a tank that will have, you are not doing any other naval architecture course now this semester, are you doing? Marine construction, okay, okay, then I do not have to say that. Okay. So, from a double bottom, there is a double bottom tank which has two two layers. So, from a double bottom tank, it is ballast water is moved from a point from a double bottom tank which is 80 meter forward of AP to another tank which is 195 meter forward of AP. So, there are two tanks, there is a tank that is 80 meters forward of AP aft perpendicular and another tank which is 195 meter forward of aft perpendicular. So, from one side, from one to the other, ballast water has to be moved, as a result of which the ship should become even keel. Now, you are given the MCTC equals 210 ton meter per centimeter, LCF 95 meter forward of AP, then the length of the ship is 200 meter. Okay. Now, you are told, the question is how much ballast has to be shifted. Okay. Now, first of all we can find how much distance has to be shifted, 195 minus 80. So, 115 meters. This is the distance through which a weight W of ballast water has to be shifted. This is what we need to find out. Okay. Now, what is the corresponding change of trim? So, of course, we are finding the minimum amount of trim, trim that is, or rather what should I say, minimum amount of motion means even keel, it can happen in many ways. The minimum amount of motion required to produce an even keel, that is what we find out. Therefore, the minimum will be the change of trim, that is one is at 12, the other is at 11.2. So, that much trim has to anyway happen, whichever way it happens, means whether this goes down a little and this goes up a little, or this goes down completely, whichever way it happens, finally this difference has to be sorted out, that difference should become 0 because it is even keel. Therefore, the change of trim should be 12 minus 11.2, which is equal to 0.8 meters. This much of change of trim should be required. Now, this formula I think we have defined some time before, should be okay. Yeah, this is that formula. Now, we have said that change of trim is equal to moment changing the trim divided by the MCTC. We have defined a formula like this. Okay. Now, what is the moment changing the trim here? That is all. So, the weight moved here is W and the distance over which it is moved is D, that we have already know. This is the moment that is causing the trim divided by MCTC. This W we do not know, okay, this, but we know this is equal to 0.8, that is, it is just a solution, is equal to weight we do not know, distance through which it moves is 115 meters, MCTC is given 210 tons. So, this will give you W equals 146 tons. That means, this much of weight has to be moved from one tank to the other, so that the ship becomes even keel. I guess actually the question has a second part, that you have to find the final draft. You have to find the final draft aft and forward. Okay, that is the second part of the question. So, now, if you want to find the final draft, so what do you need to find? You need final draft is obviously you have to find it for the forward and the aft, and from the problem we know that it should become same in this case. The final draft aft and final draft forward should become same, but how do you find it separate? But obviously we find it separately, because we have yesterday derived some formulas to do them separately. For that we do it like this: change of trim aft side is equal to this formula. Okay. This is T aft is equal to L by L. L is the distance of the, I think, center of flotation from the aft perpendicular, divided by L is the total length of the ship, into total change in trim. Total change in trim is 0.8 meters or 80 centimeters. So, this will come to 38 centimeters. So, this is the change of trim aft. Similarly, you find the change of trim forward. Actually, that is very easy. You do not need to do it as such. You can just subtract from the total change of trim. Means the total change of trim is 80. You subtract the change of trim aft, you will get the change of trim forward. But the real formula is this. That is again the same thing. Okay. So, this will give you the change of trim forward. Now, how do you find the final draft? It is like this. You are told the initial draft. The initial draft, let us take aft forward side. In the forward side, the initial draft is given to be 11.2. To it, you are adding this trim. Okay. And aft, initial draft is 12, and in this case, it is trimming. This you have to check actually, means one of them, when it is trimming, one of them will always be positive and the other will be negative. You have to see where the weight is moving. You have to see here. For example, see, you are moving from 80 meters to 195 meters of AP. So, you are actually moving it forward. So, the forward will go down. Okay. So, that will be positive, it will add up, and the backward will, the aft side will go up. So, it will become negative, that you have to check each time. So, this is 0.38, this will also become 11.62. Okay. Therefore, this will give you your the final draft in the forward and aft section of the ship as a result of shifting the weight from here to here. Forward is shifted here as a result of the shifting of the weight to the forward side. The forward side of the ship will go down. Therefore, its draft will be initial draft plus trim. On the aft side, because of this going up, it will go up. Therefore, the final draft will be initial draft minus trim, and not trim, change of trim actually. And note that change of trim will not be the same forward and aftward. It will be given by change of trim forward is this. That means that out of the total change of trim, some will be due to the, some part of it will be due to the change of trim aft, some part of it is due to the change of trim forward. Thus, you can really, instead of when I say this, probably you cannot imagine it why it is happening, but if you look at that figure which says that trim aft and trim forward, then you can see that it is exactly correct. So, trim aft plus trim forward, change of trim aft plus change of trim forward will give you the total change of trim, and depending on how the weight is moving, it will either be the sum or the difference will give you the draft, final draft. Okay, then now suppose you have a ship and this is your initial water line W0 L0, and now this is your center of flotation F, and suppose that initially you add a weight here exactly above F, some weight W is added, small w is added, and once you add the small weight W to the exactly above the center of flotation, the ship will sink. It will not trim, but it will sink. Okay. Now, once it sinks, suppose then you move this weight aft to some point here. Okay. Now, what will be the change of draft aft? It will be equal to the sinkage plus change of trim aft. Now, sinkage, these formulas you just have to memorize. Sinkage is always given by this formula, W divided by TPC. W is the weight added, TPC is tons per centimeter immersion. Therefore, you will get the sinkage in centimeters, okay, in centimeters, not in meters. Then plus change of trim aft, and for that you have to remember this formula. I just derived it. Well, somewhere I derived it, maybe yesterday. So, L into W into D divided by L into U, it is done, it is there somewhere, euro is done, no. So, L into W into D by L into MCTC, this formula, this is the change of trim aft and this is the sinkage. So, this will give you the final draft aft. So, this formula is to be kept in mind. Now, if it is the other way around, means other way means the signs can be different. For instance, if a weight W is removed from the center of flotation, this will become negative. Okay. This will become negative, and this will also become negative, because I mean, if a weight is removed and you say that a weight is removed in this, the removed weight is transferred in this direction, which is like saying that a weight is moved in this direction, that will also be negative. So, that is that you, I mean, once you know this formula, it is just you just apply it, whether it is when it is removed you make it negative, and when it is added it becomes W becomes positive, like that. Okay, one problem on this formula, this you have to remember, it is a fairly important formula. Then okay, now you are told that a vessel is about to enter a river port over a bar, means over some, it basically I will read the question, where the maximum depth at high water is 9.2 meters. She must have a minimum clearance of 0.5 meters and is at present at the draft forward 8. See, it is like this, that is, you are told that a ship has to enter port, you are told that the depth at the port region is whatever is given 9.2 meters at high water, means that is the maximum draft, maximum depth, and you are told that you are supposed to have a minimum clearance. Okay, it is like this, that is, the ship is entering a port, this is a port, let us say. So, this is the water depth, water bed, okay, and from here water is up to this height. So, you are told that whatever it is, let it says high water, general meaning is that this is about 9.2 and you should have a clearance of about 0.5. The meaning is that when a ship enters here, first of all the ship has to be able to enter here. That means ship can at the most be 9.2 meters. That is the meaning, draft. The draft of the ship can at the most be 9.2 meters. That is the first meaning of this problem. And if you are told that it should have a clearance of 0.5 meters, it means that this should at least be 0.5 meters. That means the ship cannot be 9.2 meters, it can only be 8.7 meters. That is all. That is the meaning of this problem. So, a vessel is about to enter a port where over a bar where the maximum depth is 9.2 meters and she must have a minimum clearance of 0.5 meters. That means the ship can have a maximum draft of only 8.7 meters. That is the meaning of that. Now, it is told that the draft forward is equal to 8.4, draft aft is equal to 9 meters. Now, as you can see, this is definitely exceeding your 8.7. So, this cannot enter, as in this format the ship cannot enter the port, this port. So, some kind of trimming is required or going up, something has to happen, that draft has to change. Okay. Now, the question is how much water must be discharged? Obviously, it is going up, that means they are going to discharge water. The word discharge means it is taken out of the ship, okay. It is not shifting inside the ship. Then they will say water is to be relocated, something you will understand. Discharge word means it is going out of the ship. That means the ship will go up as such, not just trim, it is just parallel, not sinkage, the opposite of that, parallel floating, going up. Now, how much water must be discharged from an after peak tank with an LCG of 7 meters forward of AP? Okay. Now, we will do the problem, it will be clear. Okay. Now, from the statement of the problem itself, as I said before, the maximum draft you can have draft forward is only 8.4, that is okay. The maximum draft that aft can have, we have seen, is only 8.7, 9.2 minus 0.5 clearance. So, 8.7 meters only it can have, but the present draft is 9 meters. Okay. It is given, the of we are, let us forget the forward side, it is less than 8.7, it is okay. Therefore, the present draft is 9 meters. Therefore, that means about 0.3 meters it has to go up the aft side. That means this should be the change of draft aft should be about 30 centimeters. Okay. Then now you are asked, you are told okay, this is another thing you should take care, that is you need to figure out, the problem finally comes down to finding what is the weight transferred or weight discharged and what is the distance. Two things, that is, there can be two possibilities. First, you are discharging a weight, means the weight is removed from the ship itself, that is not moving inside the ship, it is just removed from the ship itself. When you do that also, you will need to find out the position at which that weight is taken out. You will need the LCG for that. Okay. That is definitely, we will see why it is required, but you need that to find some moments. And number 2 is, in case the ship is transferred, I mean the water is transferred inside the ship, that is, suppose that you say from a forward tank to a backward tank, you need to find the distance over which it is transferred, that is also important. So, two distances come important, one is the position of that LCG and other is the distance through which. In this problem, we are not actually shifting water inside, we are just discharging it. So, you need to find the position where the water is discharged, because then only you can find the moment lost. See, some weight is lost at some point, means some moment is lost at that point. To find that moment, you need to find the distance from the, you need to find the distance where the weight is removed. Now, another thing is, you need the distance where the weight is removed the distance from the LCG, that is center of gravity of the, we will look at this problem, this will become clear. That is, let's suppose that the plan view is like this of the ship. Therefore, somewhere here you have the center of flotation. Okay. Then now depending on this center of float, we are always say that the ship trims or moves, everything we have done about trimming, whether it is trimming aft or forward or parallel sinkage, everything is about the center of flotation, not about any other center, not even the LCG of the ship. It is about the center of flotation of the ship. That is mainly because then it is how it trims, and it is because volume of becomes a volume equal to volume forward. That is because of the reason why it trims about the center of flotation. So, every measurement we do here, we do it about the center of flotation. So, this weight that we are removing in this problem, we need to find where it is being removed. So, let us look at that. It is said that you are told that the water is discharged from a tank 7 meter forward of AP. So, this we will consider as AP. So, 7 meters forward of AP, here 7 meters forward of AP water is discharged here, but note we do not want the distance from AP, we want the distance from F, okay. That is W, I mean that is W into D, or any D that we are using moment, we are always taking moments about the center of flotation, not moments about the AP, okay. So, we need the distance from this, that means we need the distance of the center of flotation. You are told that LCF is midship, exactly midship. That means you need the length of the ship. Now, the length of the ship is given to be 220 meters. Okay. Therefore, midship is 110 meters from aft perpendicular. So, this is 110 meters. Therefore, the distance between F and this position where the weight is discharged is 103 meters. Okay, this you have to find. This is your D, the position where the weight is discharged. Okay. Now, therefore, this is a we have derived a formula here, this formula, that is the change of draft is equal to sinkage plus change of trim. It is W by TPC plus this. Now, this formula is what we are going to use here. It comes to be from our previous part, we see that the draft has to change by 30 centimeters. If the ship has to cross the cross that port, or it has to enter the port, its draft aft, in the aft side, the draft should be reduced by 30 centimeters, otherwise the ship cannot enter, we have seen that. Therefore, the change of draft aft, first we will, therefore, the change of draft aft, we are doing the minimum, okay. We can of course make it lesser, but there is no point in that. Change of draft aft is 30 centimeter, and we use the formula change of draft aft is equal to W by TPC plus L into W into D by L into L into MCTC. Okay, this formula you have to use. Now, note that in this case everything will become negative, because it is a discharging of weight. Therefore, it actually will become, it is a decreasing of draft. So, it will be minus 30, minus 30 will become minus W by TPC minus L is the distance of the center of flotation from, you have to know what each of these terms is, that is very important. L, I will repeat, L is the distance of the center of flotation from the aft perpendicular, that is small l. W is the weight of the water, or the weight that is discharged or added. D is the distance of the point where the weight is discharged or added from the center of flotation, that is very important. Okay, it is the distance from the center of flotation. You will see that when if you look at the derivation, Otherwise, of course, you cannot know. If you do the derivation, you will see that d is the distance from the center of flotation, L is the length of the ship, then MCTC is the moment to change the trim by 1 centimeter, and this has to be written in centimeters, because see, W divided by TPC will give you the sinkage in centimeters, not in meters, because TPC is tons per centimeter immersion. That is how TPC is defined. So, W by TPC, similarly L into W into D by this will also give you trim in centimeters. So, you put 30 centimeters minus this thing. So, here the center of LCF is midship is given, which is total length is 220. So, midship is at 110. So, LCF is 110. Weight that is to be added or removed, so we calculated it, I think, or is it given? No, that is what you require to find out. So, W into the distance where the weight is to be removed is here, this thing 103, distance from the center of flotation 103, is it 103 meters? Yes, 103 meters, divided by L is the length of the ship 220 meters, and MCTC is given for this problem 125. So, so you just solve this equation for W, okay. That is all, only W is the unknown. So, TPC, yes, TPC is also given 25 tons per centimeter, okay. Now, that is all. So, everything is known in this problem. You just need to remember this formula, that is the total change of, just need to, it is very logical only. Total change of draft will be the change of draft due to parallel sinkage plus the change of draft due to trimming, and whether plus or negative you just check. And when you put these equations, the change of trim equation, this is very straightforward, very simple. This is I do not think you can derive as such in. So, this you might have to remember. I mean, you can derive it of course, but you better memorize it, I think. L into W, and you have to know exactly what each term stands for. L, W, this D for instance, it is not the distance from the aft perpendicular. D is defined to be the distance from the center of flotation. That is very important, otherwise the answer will be wrong. Okay, then in this problem you just solve for W, it becomes 66.4 tons. Then, so this is the amount of water that needs to be discharged at that point. Then also you can also find the final values of trim, the final values of draft. That this procedure is exactly the same. The change of trim is given by W into D divided by MCTC. There is no difference to this step, it is always done like this. Change of trim is equal to W into D by MCTC. So, W we have just calculated 66.4 tons into D is the distance through which it has moved, distance from the center of flotation, divided by MCTC 125. So, you get that, and then you need to find the change of trim in the aft side. This formula also you just have to remember, L by L into change of trim. So, once you have your total change of trim, you need to do L by L into change of trim will give you the change of trim aft. I mean, I think you can do that. Then similarly, you have to find the change of trim forward, that will give same thing, it will be like this, L minus L by L into change of trim, that you can find. Now, so this gives you the change of trim. Okay. Note that there are always two things, change of trim and parallel sinkage or parallel rise. So, here there is also a rise because of the discharge. So, that rise will be given by W by TPC, that you just do, and that will give you your parallel rise. Therefore, your final draft, so it is always like this, the final draft forward in this case, final draft forward will be okay, we have to see in this case in the aft side a weight is removed, therefore forward will go down, forward is therefore plus and aft is therefore minus. Okay. So, final draft forward will be initial draft forward whatever is given, initial draft forward plus the trim forward minus parallel rise. Okay. So, this will give you your final draft forward, and your final draft aft will be your initial draft forward minus trim not forward, aft. So, final draft aft will be initial draft aft minus trim aft minus parallel rise. So, this will give you your final drafts. So, it becomes 8.64 and 8.7. Now, one special case that is possible is that in this equation, in this thing, where is it? Yeah, in this, suppose you have a change of draft aft given by this formula, this plus this. Now, it is possible that in a particular case you can have such that the change of draft is 0, but these two still exist. That means, you can, for instance, this can go down, it can sink and this can trim up, such that the two things can cancel out, or this can rise and this can trim down. So, that is a special case that is possible when you can, your change of draft is 0, but still there is sinkage and trim. Okay. All right. So, in such a particular case, what you are saying is that 0 is equal to sinkage plus change of trim aft or you will have sinkage is equal to minus change of trim. So, you will have W by TPC will become equal to L into W into D divided by L into MCTC. So, this formula, it is just, and it is just a particular case. So, in such a particular case, so suppose you are adding a weight in this particular case, the position at which you add the weight, you will get like this, W into L into MCTC divided by TPC into L into W. Oh, W will cancel out. So, in this particular case, it does, you see that it does not depend upon how much weight you are adding, provided you add weight at this position D in such a fashion, means if you design your D to be this, it does not matter what weight you are adding, how much weight you are adding, your draft will always be constant, draft aft will not change. So, at that particular point where D is defined by L into this divided by TPC into L, small distance, if in the ship at that point there is one particular point such that at that particular point if you add whatever be the weight, your draft will not change in the aft side and the forward side also. Okay, that forward side it might not be, it might be, it might or might not be same, it can change, it will change most of the case.
So, it will change.
Why do you say that?
So, this equal to this and the forward side will be either plus or minus.
Sir, if the weight is added on the aft side, then the forward will rise and there will be a sinkage, they can cancel each other. So, it's possible.
It is possible, that is what I am still saying, it is possible they can cancel out now, that is why I said it can happen also. Huh?
Sir, both the things at a time cannot happen, either draft will be 0 for the aft or it will 0 for the forward.
It won't happen at the same time.
Yeah.
Draft will be
So suppose if sinkage is negative and the change of trim aft is positive,
Okay.
then the sinkage also will be negative for the forward,
Yes.
and the change of trim will
Oh, that will always be okay of the opposite sign.
because the sinkage will be same for all the sides.
Sinkage will be the same for both sides. Yes. So if one is negative, the other will be positive always. Yeah, I think that is correct. So it can, it's not that it can be, I guess it will always be there, that there will always be a yeah, I think there will always be a trim in the forward side, though the trim on the backward and the off side is always 0. I mean it can be 0, if it is 0 there will always be trim on the forward side. Yeah, one. Okay.
But reverse can also happen, sir.
What is reverse?
Like trim in the forward is 0.
No, that is a different case. I am saying that in case the draft backward in the aft is 0, can the aft forward also, not aft, if the draft in the aft side is 0, can the draft in the forward side also be 0? That is what I am saying. That is not possible, but yeah, draft in the forward side can be 0 and the draft in the aft is not 0. That is also a possibility, but that is not what we are talking about here. Okay. Now, okay, there is one problem on this, we will do this. Now, you are told that a vessel is floating at a draft forward of 7 meter, draft aft equals 8 meter. Now, you are told distribute 600 tons of cargo between compartment 1, which is at an LCG of 75 meter forward of AP, to a compartment 2, which has an LCG of 130 meter forward of AP, so as to maintain the draft at aft constant. Okay. So, you are going to transfer 600 tons of cargo and it is to be transferred between, like if this is a ship, at one point 75 meter forward, 135. So, 75 meter forward to a region which is 130 meter forward. From here to here you are shifting a weight. So, you are told how much distance it is shifted, that is also told. And you are told that the draft aft should remain constant, it does not change. You are asked to find the final draft forward. You are given the TPC, MCTC, LCF and the length of the ship. So, you are given the TPC, MCTC, then LCF means position of the longitudinal center of flotation, and you are told that the length of the ship is so much. Okay. Now, straight away we can use this formula, there is nothing much to do it actually. So, D is the distance through which the weight has to be shifted, it is equal to L into MCTC by TPC into L. So, if we just put this formula, distance through which it has to be shifted is equal to L into MCTC divided by small l into TPC. Now, this is given 180 is your length of the ship, MCTC is again given to be 180, then L is the only problem here is to know exactly what each of these small l, capital L, all those things is small w, d, etc. everything you should know, and you are told that the LCF is at a distance 92 meters forward of AP and TPC is given to be 23 tons per centimeter. So, this will give you 15.31 meters forward of AP. D is the distance from center of flotation, yes.
So 15.31 from the center of flotation it will be.
Oh, forward of okay. It is from the center of flotation, yes. Oh, actually it is written, it is like this, forward of F, forward of the center of flotation, not AP, forward of F, yes, 15.31 meters forward of center of flotation. Now, you are told that Okay, so 15.31 meters forward of center of flotation. Then you are told that LCF is at a distance of 92 meters from the aft perpendicular. Then now the weight has to be moved from 15.31 meters forward of F, which means 92 plus 15.31, which is 107.31 meters forward of AP. Okay, forward of aft perpendicular. So we are just writing it like that. That is the distance from AP. Then that is the distance from AP. Okay. Now you are told that compartment 1, there is the movement of weight is from like this, from 75 meters forward of AP to 130 meters forward of AP. So 75 meters to, this is compartment 1, to compartment 2, which is 130 meters forward of AP. Now 1 minute, that is the G of 1, G of 2. Um, 30 G from aft perpendicular.
So here we are adding this 600 tons.
600 tons is added. No, it's not like that. It's actually told distribute 600 tons. Means
It is added, some of that weight is added at 75 meter and some is
exactly, some of that weight is added at 75 meters and some of that weight is added at
so
130 meters.
Mass of that 600 tons should be 15.31 from center of flotation.
Center of mass will be 15.31 from the center of flotation. Yes, that is what they have done. And therefore, if W, therefore there are two things at 75. So this thing, this 15 point, let's see, 15.31 or forget that, we take this one distance from AP, because everything is given as distance from AP. This 15.31 meter forward of F is actually 107.3 meters forward of AP. Okay. So let us take that 107.3 meters. So somewhere around here, okay, somewhere around here you have the G of the, means let us say that a W amount of weight is added at 75, 600 minus W amount of weight is added at the other point at 130, as a result of which your center of gravity becomes at 107.31. that is a problem. So what you do is you say that the moment like this distance, okay, it is 107.31 minus 75, that will give you 32.31, that is this distance, right, and at this distance is 130 minus 107.31, right. So the first distance, this first distance 32.31, and let us assume that a W weight is added on that side. If you have a doubt, I will just, this is 22.69 into 600 minus W. Is this clear? All we have done here is, the problem says that there are two tanks. Okay, there is a compartment 1, compartment 2. There are two tanks. In that compartment 1, I am adding W weight. Another tank I am adding W2 weight, such that W1 plus W2 is equal to 600 tons. That is given, but we do not know how much is added in each of them. Now, from our first part, we saw that the net center of gravity of the weight added is at this point 107.31. Now we just find out the center of gravity, that is all. So this 32 point, I think this is very obvious, it's it gives you, therefore what we are saying is that a W of 248 tons of weight is added on first compartment, the remaining whatever 352 tons of weight is added in the second compartment, and when you add it like this, it will produce a center of gravity at some point. I mean, it is like the total amount of weight of 600 tons is added at the center of gravity, when you are adding something here and something here, it is like adding the total weight at the center of gravity, and when you are adding at the center of gravity, this formula holds, that d equal to L into mctc, that d is the only thing you have to take care is that d is the distance from the center of flotation and not from the aft perpendicular. That conversion you have to do. So, this is the problem as such. Then this is the main part of the problem. Then of course, you and you are also asked to find, once this weight is added in this fashion, what is your final position of draft. Okay. That is the same thing we have done many times. You do this, that is, first you find the sinkage. So, here we are adding some weight in one point and point. So, total weight added, this is very straightforward. So, you are told that the weight added is 600 tons is added by 23 is equal to whatever 26 centimeter. So, this much of sinkage you get. Then, and these two formulas, I think just use the same thing always. Okay. This formula should be used all the time. Change of trim is equal to moment changing the trim divided by mctc. Here slightly tricky thing again, moment changing trim. What is the moment changing trim? It is W into D, but what is that D? D is 15.31, because D is the distance from the center of flotation again, not from the AP. It is only for doing the problem that we take from AP, because it is slightly easier to think. W into D by mctc, which will be, in this case, weight is 600 tons is added and D is 15.31 divided by your mctc. That will give you your total change of trim. Then you need to find the change of trim aft, which is using this formula, total change of trim. Then change of trim forward, which is total change of trim minus change of trim aft. Then okay. Therefore, you get your change of trim forward, and then your final draft is your initial, that again you have to check. In this case, weight is added in two sides. So, you have to see which side goes down and which side goes up. In this case, 248 tons is added in the back side and aft side, and 352 tons is added on the forward side. More weight is added on the forward side. So, the forward side will go down. So, that will be plus, this will be minus, aft will be minus, that you have to check. Therefore, the final draft forward will be initial draft forward plus the trim. Is it sinking or its weight is added? So, it is sinking plus sinking. Okay. That will give you the final draft forward, and the final draft aft will be initial draft aft minus the trim plus the sinkage. Huh?
Change of trim of aft is 0.
Change of trim aft is, oh, that is what we are tried to do. Yes, change of trim aft is 0. So, that will be, let us see. Yes, actually you are right. The change of trim, they are cancelling out each other. So, the change of trim aft is not 0, change of trim aft plus the sinkage is 0, change of draft aft is 0, okay. Change of trim aft is still there. So, two things are there, change of trim and there is a sinkage, they sum up to produce a change of draft, where change of draft is 0. Okay. So, yes, change of draft is 0, in this case they are cancelling out each other. So, this will give you your initial draft, final draft in the backward and forward side. That is this problem. So, this is one type of problem that you can expect. There are a lot of course, these things you can derive very quickly, but lot of things you have to really memorize also a lot of these formulas. Some of the important things are, first is the expression for change of trim, that definitely has to be remembered. Then once you have the total change of trim of the ship, you need to be able to find out the change of trim in the aft direction, aft side, and the change of trim in the forward side. And then you need to know what is the parallel sinkage expression for that. Okay, that is more or less enough. Then other things are just applying it. You are saying that the draft is 0, you set that equal to 0, that you can derive. Okay, so once you have this, I think you can do. I think we will stop here. Okay, thank you.